today's presentation, we'll be discussing a few of the less prominent celestial bodies, those being asteroids, comets, and dwarf planets. Despite their relatively small size when compared to planets and especially stars, these celestial objects are no less important or interesting. Each carries with it a specific history and set of attributes that make it distinct, and our presentation will serve as an educational one, exploring the finer details of what exactly asteroids, comets, and dwarf planets are, how they work, and what makes them such interesting additions to our universe, galaxy, and solar system. The presentation will be broken into 3 distinct parts, each covering one of our major topics, so please enjoy. First on our list of celestial objects is asteroids. Often referred to as minor planets or planetoids, asteroids are small, rocky objects that orbit the sun. They are an essential part of our solar system and offer valuable insights into the formation and evolution of celestial bodies. Asteroids vary in size from a few meters to hundreds of kilometers across and occupy a unique niche in the cosmic landscape. Asteroids are primarily composed of rock and metal, but their individual compositions can vary significantly. They lack the distinct features of larger bodies like planets or moons, which makes them challenging to observe. Their irregular shapes, often resembling lumpy potatoes, further contribute to their mysterious allure. Asteroids vary in color and brightness, with some appearing dark and others reflecting sunlight more brightly. Asteroids are typically split into 3 categories based on composition. S-type asteroids are composed of silicate materials and metals like nickel and iron. They are typically brighter and are located in the inner asteroid belts between Mars and Jupiter. C-type asteroids are the most common and are composed primarily of carbon and silicate materials. They are relatively dark in color and are often found in the outer asteroid belts beyond Mars. Finally, M-type asteroids have a high metal content, primarily consisting of iron and nickel, and they can be found in both the inner and outer asteroid belts. Asteroids are not merely enigmatic celestial bodies, but play a crucial role in the cosmos. They offer a wealth of knowledge about the early solar system's formation, as they are remnants from that era. Their study can provide insights into the conditions that prevailed during the solar system's infancy, which helps scientists piece together the puzzle of how our planetary neighborhood came into existence. Moreover, asteroids have captured the imagination of scientists and space enthusiasts alike due to their potential as resources for future space exploration. They contain valuable materials such as metals, water, and rare minerals. Mining these resources could revolutionize space industries, making asteroid mining a potentially lucrative venture. However, the significance of asteroids extends far beyond research and resource extraction. They also pose potential threats to Earth. While the vast majority of asteroids are situated in the asteroid belt between Mars and Jupiter, some do stray from their orbits and come dangerously close to our planet. These near-Earth asteroids, as they're called, have the potential to impact Earth, which could have catastrophic consequences. To mitigate this risk, astronomers and space agencies worldwide actively monitor and track these objects, developing strategies to divert or mitigate any potential threats. Our second main topic in this presentation are comets. Comets are formed by frozen leftovers of dust, rocks, or ice. As they get closer to the sun, comets heat up, spewing gases which form their tails. The tails can stretch out for millions of miles, and billions of comets are orbiting in the Kuiper Belt and Oort cloud. The current number that we know of is greater than 3,800. Due to their composition, comets have earned the nickname of dirty snowballs. Comets are made of 3 distinct parts: the nucleus, the tail, and the comma. The nucleus is made from ice, gas, and rocky debris, and after the energy from the sun creates the comma, it flows around the nucleus to form a fanned-out tail behind the comet. The comma is the gas and dust atmosphere around the nucleus that forms when the sun warms up the surface of the comet. And there are 4 types of comets in our solar system, those being periodic, non-periodic, no orbit, and lost comets. Periodic comets orbit the sun in intervals anywhere from 20 to 200 years. Non-periodic comets take more than 200 years to orbit the sun, or might not even orbit around the sun at all. Short-period comets orbit the sun every 20 years, while long-period comets orbit every 200 years or longer. Comets that orbit in periods between short and long are called Halley-type comets. For a comet to be labeled as no orbit, it indicates that no reliable orbit could be calculated for that comet. Lost comets are comets that were not detected during their recent different perihelion passages. Referred to as the most famous comet because it led astronomers to understand its repeated appearances, Halley's Comet was named after English astronomer Edmund Halley, who examined comets documented approaching Earth in the years 1531, 1607, and 1682, theorizing that the different comets were actually one and the same. Halley's Comet moves backwards around the Sun when compared to Earth and orbits on a plane that is tilted at 18 degrees when compared to the plane of Earth's orbit. The retrograde or backwards motion of Halley's is unusual for a comet, and the comet has an average orbit period of 76 Earth years. Halley's Comet has a diameter of 6.8 miles, and a day on the comet would be the length of roughly 2.2 Earth days. When Halley returns to the inner solar system, the nucleus sprays ice and rock into space, which results in a 2-week meteor shower each year. The Eta Aquarids in May and the Orionids in October. The Halley family of comets are a group of comets that are similar to Halley's orbital characteristics. These comets originally came from the Oort cloud. Finally, on our list of main topics, we come to dwarf planets. There are a total of 5 dwarf planets in our solar system, those being Pluto, Eris, Ceres, Makemake, and Haumea. Dwarf planets are, like the main planets, rounded and orbit the Sun. However, they lack the ability to clear objects from their orbital path, thus disqualifying them from being full planets. They are smaller than regular planets, but still are not moons. Pluto was discovered in 1930 and labeled a planet, but was reclassified as a dwarf planet in 2006. It has 5 moons and takes 250 years to orbit around the Sun. The first close-up images of Pluto were taken in 2015 by NASA's New Horizons project. Ceres is the largest object in the asteroid belt that lies between the orbits of Mars and Jupiter. Ceres contains about a third of all matter found in the belt, and its near spherical shape means it is not considered an asteroid. It is the only dwarf planet inside the orbit of Neptune. Makemake was discovered in 2005 and is located in the Kuiper belt. It takes over 300 years to orbit the Sun and was named after the Rapa Nui god of fertility. Haumea, also located in the Kuiper belt, takes roughly 285 years to orbit the Sun, but rotates very quickly, completing one rotation in roughly 4 hours. Past Neptune, no current instrument can see a visual image of the surface on Eris because it is so far away. The dwarf planet takes 557 years to orbit the Sun and is smaller than Pluto. So today we've covered comets, asteroids, and dwarf planets, and hopefully provided you with a better understanding of each and how they fit into our wider solar system. We've broken down the main parts of all, and as a result, have come to better understand the inner workings of space itself. It's a broad and expansive place full of interesting and fascinating objects like those we've covered today. Thank you for watching our presentation, and we hope that our video might inspire you to learn even more about the universe that surrounds us.